Hey, what's happening, guys? Rust Belt Mechanic here, back with the SP Tools Garage. We're going to be doing part 2 of our automotive how-to series on electrical basic diagnostics. Today we're going to be going in depth with test lights, some extra training with our multimeter, as well as showing you guys the basics and the importance of relays in DC electrical current. Alright, today we're going to be starting in on test lights. Now normally a lot of trainers or schools are going to show you guys these to start off with, and I thought that the basics from part 1 in this series was going to be a little bit more important, and now we can get into the use of these test lights so I can show you the good part as well as the bad part about using these to be able to diagnose your DC electrical systems. Now we've got 2 different test lights here to use, both from SP Tools, out of which I forget the part numbers. We've got SP61011 and SP61015. Now the differences in these are that this one, the 61011, is going to be a standard bulb style circuit, just going to be able to run a standard interior bulb from an older vehicle, and we're going to get into that one. And then our 61015, this one is going to be an LED heavy duty unit. This one's going to be able to test both 12 volt and 42 volt systems. So there's some pluses and minuses to using each one of these in your circuitry diagnostics. Now the first one we're going to use today is the LED test light for the diagnostic unit here, and we're going to hook this one up to our ground, which would be right here on the battery portion of our E-Trainer test board. And actually our ground is up here as well, so this will be a lot easier for us to hang on to. Now for using these test lights, how they're actually going to work is it's going to be kind of like your meter, except for actually reading your numbers on the screen. It's just going to have a little LED light built into it. So we've got our clamp end onto our negative post, and then if we touch our positive post, we can see that we get a nice little blue LED light lit up right here. And at any point in the circuit that we touch that it has 12 volts of power, you can see that we are going to have, let me turn this on, we are going to have 12 volts all throughout the circuit. So if you guys are looking for power, say for instance you're trying to diagnose a window motor or a switch, we've got this to be able to test at the switch, we're able to test at the door connector unit, and then we're able to test at the motor to see if we have power leading up to each point in that circuit. Now we're going to talk about the negative part of using an LED test light, and that is the fact that they can't really differentiate current. Now if you guys remember from part 1 in the video when we're talking about current, we've got our amperage flow here in the Ohm's test and the Ohm's law. The current flow is the most important part of the electrical circuit. As you guys remember, with a resistor, we've got a 50 ohm resistor here in our circuit. If we were to turn that on, you can see our bulb severely dims down. Now in our test circuit, when we're trying to test for that window motor, if for some reason we have something wrong in the system causing a lot of resistance, you can see that we don't have a lot of current or a lot of electricity flowing to make that actually work in the system. So here's the problem with an LED test light. These little LEDs actually light with an extremely small amount of current. So we have our system lit with the normal 12 volts and our normal amount of current, and we can see that it tests and lights at each one of those points. Now if we turn our resistor on, you can see that that bulb dims down to pretty much just about nothing. Now this test light lights the exact same amount at all of our test points. Now why is that, you might say? Well, like I said, this LED actually only takes about 0.3 volts and very little amperage to actually light this LED circuit. So you don't have to have a fully functioning circuit always to make this test light come on and light perfectly. So you can see still with the resistor turned on, it's going to be lit up just fine, and then turn our resistor off and nothing changes within that light. So that is going to be the downside to using an LED test light is you might still have high resistance within your circuit, but you're not going to be able to tell the difference in that. Now we're going to go over to our SP61011. Now, what for most people would say this is a cheaper or more cost-effective test light because it doesn't have all the fancy internal circuitry resistors to be able to run different voltages and different power sources. But for testing these 12-volt circuits, you don't always need that for more respectable results. Now with this unit, we're going to go ahead and connect it at the same exact ground point that we did before on our HD unit. And we can see when we touch our power, you can see that we have our test light light up. Now this is going to be more of an incandescent light source, and that's because this is a standard filament bulb. And our resistor is still off, making sure, and we've got our full light source and our full voltage of power up to that light bulb. Obviously after, our amperage is being used up by that bulb, and we're not going to show any voltage after that point. Now the cool part about these incandescent bulbs is that they do show the difference when you have a different amperage running through this circuit. So we're going to show you guys right here. We're going to show it turned on right here with the full voltage. Now if we turn our 50 ohm resistor on, you see how dim that got? Very, very dim. Almost to the point where you can't even hardly tell that that test light is lit. You can see right there, the light is also very dim at that point as well. We take this off, you can see that light bulb there change down because it uses more amperage and more electricity to actually light the filament within this bulb. You might consider this one more of like an interior dome light bulb. It's going to take almost 3 volts at least to start lighting this bulb. Now the advantage to using this one, like I said, it's going to be, as you guys can see, able to tell the difference in amperage flow in the circuit. So when we go back to our window regulator circuit, if we're trying to see if the motor is running or not, we're able to test at all the different spots. And if for some reason we had, say, a pinch wire between the door and the panel of the vehicle, you can see that we're going to have a very, very dimly lit bulb. So when you guys are using these, give yourself a little bit of practice in being able to see what this bulb looks like when it's lit with a full 12-volt circuit and something that's lit from, you know, a very small voltage or a dimly lit power circuit. Let me cut there for a minute. Cut, meow!
I'm sorry, are you saying meow?
Am I saying meow?
Listen here, meow.
Meow!
Alright, now that we understand how to test these circuits with our different amperage style test lights, now we're going to be getting into the importance of amperage in use within these circuits by use of relays. Now we need to be able to use relays in these electrical currents to be able to control large electric current uses. So like for instance in a vehicle, we need to use our small ignition switch to be able to power our large amperage starter motor. Now if you thought that that little ignition switch could handle all of the electricity and amperage load to be able to start up the engine, yeah, that's not so much the case. So that's the reason that we use relays. Now let's go over to our board right here and let's illustrate exactly how a relay is going to work. Now your relay is going to have 5 standard pins. We have pin 30, 85, 87, 87A, and 86. Those are the 5 pins on the standard relay that you might see. Now some relays, they may not have an 87A or one of the pins in the middle, but generally this is what you're going to see in a standard relay. Now when we look at the inside of what is actually inside of our little relay, we've got a switch between 30 and 87, and then between 85 and 86 we have a coil winding of wires here as well. Now how is this going to work, you might say? We're going to want to be able to control a high load circuit with a very low amperage switch. So like you're saying, our amps and our voltage need to be able to go in with each other in this equation. A large amperage circuit is going to be able to create more resistance within its motor, which means it needs a higher voltage output. So on these circuits, we're going to be using a really tiny switch and a tiny amount of voltage, a tiny amount of amperage to be able to control a higher amperage circuit. So we're going to consider our 85 and 86 side of this relay our control side of the circuit. Now when we put power and ground, so positive and negative, to our relay, this is going to energize our coil within our relay. Now, we haven't really gone through the importance of coils or anything, but that is going to pretty much create a magnetic array to be able to pull this little switch filament over from one side or push it over to the other. That's how the internal portions of the relay are going to work. So on our control side, we're going to power our 85 and 86 side. That will energize the coil and will create a magnetic field, which pushes our little arm right here over to our 87 side, which in turn will then connect our circuit between 30 and 87. Now this 85 and 86 side, this might only have really small, like 22 gauge wire, and it only needs to run about, you know, an amp and a half or so to be able to make this coil work. Now when it slides the connector over within the circuit to energize from the 30 to the 87, that is going to put full power through that circuit. Now this is going to be our higher amperage side of the circuit. It's going to be running a lot bigger wire, might run up to say like 14 to 12 gauge wire, and we're going to be able to put up to 20 to 30 amps through this side of the relay. So that's going to be able to show how we can use a really small, tiny switch and a tiny amount of voltage to be able to control a higher amperage and higher voltage side of circuits. Now you guys can see the inside portions of this working relay right here. What I was telling you about the coil windings, it's a lot of windings of wire inside the relay. This is going to be the one that connects from 85 to 86 and makes that magnetic field. Now when that magnetic field is energized, that is when it's going to pull this larger section right here over to connect the 30 and 87 side of the pin. You guys can see that this little arm is able to move back and forth. That is what will energize your higher amperage side of the circuit. So just a little inside view of what the inside of a relay actually does and looks like. Now for the final part of this video, this is going to be one of the most important diagnostic skills that an early technician can learn when diagnosing these electrical circuits, and that is the difference between testing for voltage and actually doing a voltage drop test. So like I said earlier, when you're using these test lights, you may or may not be able to see the function of resistance within the circuit, especially if you're using an LED test light. We can see on these circuits that we are testing at 12 full volts, and the test light lights, even if we turn our resistor on, it still lights our test light. So when somebody asked, did you test or check for power at a certain source? You said, yes, I used my test light and I checked for power. Now, yeah, that might show you power, but that may not show you the full power amount that you can see there as well. Now, if for some reason you are not getting voltage at your final destination, that means there's high resistance or there's some kind of an open within the circuit. Now, what some people will go to tell you to test or use is going to be the ohms or the resistance function on your meter. Now, that is going to tell you the ohms or resistance in the circuit between a two set of points, and that is going to be within a circuit that is not functioning at that exact time. So we may be able to see right here that our resistance from point A and point B is going to be pretty much zero because it is directly in contact with it. And also from here we can see our 50 ohm resistor. That is showing you the resistance value of that resistor. Now what if for some reason we had a very small little nick here in the system, or a small amount of the wires had corrosion build up within them? Now, if you were to check with an ohms resistance, you could tell that yes, there is continuity between A and B, but for some reason, the light or the motor isn't working. That's where you guys really need to be able to check and know what voltage drop is. For voltage drop testing, you're going to need to have a fully functioning powered up circuit. So in this one, we are going to turn off our resistor, and our light circuit is functioning from positive all the way to ground. Now for voltage drop testing, we want to have our meter on voltage. We're going to put it over on volts. Check that our meter is working. Yep, putting out a full 12.2 volts right there. Now when we're going to test our functioning of the circuit, we're going to test just in certain sections. So we're going to put 1 meter lead here and 1 meter lead up on the next functioning portion. And we can see that we're only dropping about 7.9 millivolts. Yes, this is auto ranging, that is not full volts, that is millivolts. Now we know that our resistor is here in place, making it just like we have a broken wire or resistance in it. And what kind of a voltage drop are we seeing? A full 6.27 volts. That means somewhere within that circuit we have a higher resistance value. That is causing our light to be very dim, or our circuit to be not functioning very well at all. Like if we were to have that window motor circuit that we're testing, it may not even be able to power it up at all. So checking voltage drop is the best way to be able to check a fully functioning system as compared to using a test light or even using your ohm setting on your meter as well. Now the way you take your voltage drop reading is going to be absolutely superior, like we said, in comparison with the test light or with using your ohms reading here on the meter. That is going to give you an actual value that can be shown with a voltage drop shown on your voltage reading within the meter. That is always going to be the best way to be able to test a questionable circuit within the reasonable rate of what you're testing. So you need to make sure, take that into mind, if you are checking for voltage and how well a circuit is functioning. If it's questionable at all, always use the voltage drop test. Don't always rely on a fancy little LED test light or even the ohms reading on your meter. Always use the voltage drop test. Alright guys, that's about all the information that we're going to be putting into part 2 here on the series. This has been the Rust Belt Mechanic. For any other questions that you have, go over to www.sptoolsusa.com. Go grab a tool and get wrenching.